Okay, now we're going to continue with the table method, and the table that I've got here is the one that we had just a few in the last video. Now, in the prior problem, which two of the variables have been assigned the value of 0 are called basic solutions, but the basic solutions that are feasible are called basic feasible solutions. That's when all the variables are greater than or equal to 0. Now, since the basic feasible solutions correspond to the corner points of the feasible region for the optimal value of the objective function in linear programming to exist, then that value must occur at one or more of the basic feasible solutions. So that last statement is called the fundamental theorem of linear programming. It also sounds familiar to what we had back in the last chapter. Keep on going. Basic and non-basic variables. The basic solutions associated with linear programming problems are found by assigning a value 0 to certain decision variables, the x sub i's, and the slack variables, the s sub i's. For instance, row E right here, in the table above shows the basic solution x sub 1, x sub 2, s sub 1, s sub 2 is equal to 40, 0, 20, and 0. It's customary to refer to the variables that are assigned the value 0 as non-basic and to the others as basic. So for the solution of row E, the basic variables are x sub 1 and s sub 1, and the non-basic variables are x sub 2 and s sub 2. Now the benefit of the table method is that it gives us a procedure for finding all corner points of the feasible region without drawing a graph. But unfortunately, we run into a problem when the number of rows in that table becomes too large to be practical. The simplex method in the next section gives a practical method for solving large linear programming problems. But until then, we're going to look at an example. So the first thing I need you to do with this problem is write the E system. So put in your slack variables. Let's see if you remember how to do that. And see if you got that. And then we're going to fill out this table using this information. So x sub 1, x sub 2, I'd like you to go ahead and pause me and you go through this and see if you can come up with the same thing I do, because this is pretty much what your homework's going to be based on. So s sub 1 should be 100 and s sub 2 should be 120. Okay. X sub 1, S sub 1, X sub 1, S sub 1. So that would be 100 over 15. Let me get my calculator over here. 100 divided by 15. Go frac that. So 20 over 3 should be my X sub 2. And I've got to substitute that into the second one. So let me go times. So I'm going to multiply that by 20. So that would give me that value. I need to subtract that from 120. So 120 minus that previous answer. So negative 40 over 3. So far so good. X sub 1, S sub 2, X sub 1, S sub 2. Divide by 20. So it looks like this needs to be 6. And if I put 6 up here, 15 times 6, it's 90. 15 times 6. Yep. So if that's 90, and I've got to subtract that from 100, so that should be 10 here. Very good. X sub 2, S sub 1, X sub 2. Nope. X sub 2, S sub 1, first one. Divide by 10, so this should be 10. Put 10 in here, so we can find out what S sub 2 is. So 10 in here, that would be 50. That's 0. Subtract, whoops, yeah, that's right. Subtract that from both sides. 70. Okay. X sub 2, S sub 2. X sub 2, S sub 2. 120 divided by 5. 120 divided by, well, Pooh Bear. 24. Okay. decimal 1. So 20, that'd be 240. Now if I subtract that from both sides, that'd be a negative 140. Yep. Oh, this is one I gotta go to my calculator. So second matrix. Let's go edit. I've already got a 2 by 3. 2 by 3, 10, 15. It's already 100. 5, it's already 5. 20. And then 120. So let's quit. Second matrix over, go up to ARREF. Go grab that matrix I want. I think I'll go ahead and I'll just tell it to frac it. If it's a fraction, good. If not, 8/5 and 20/5. What is that in decimal? That'll be a good decimal value, so I can do decimals too. So this should be 1.6, and this one is 5.6. Now, did you indicate who is feasible or not? Looks like B is not, E is not, everybody else is. Alright, so plug your values x sub 1, x sub 2 in here, only for the ones that are feasible. This should be 0. That one's always easy. So I shouldn't have to worry about this one. If I put 6 in here, 25 times 6, 150. Okay, that should be 150. 10, and that'd be 350. Don't have to worry about that one. So I've got to put 1.6, so 35 times 1.6 plus 25 times 5.6, 196. So my maximum value is 350, and it occurs at the corner 10, 0. Now, I think there's a few problems that I asked you to go ahead in the homework and graph it to see if it does coincide, and I just went ahead. Now, it didn't take us much time to do this. You need to look at this paper, page 4. This is not in your handout, but I need you to check out these corners and the objective function and see if that's not the exact same thing that we've got. It took a bit. I had to make my graph and go get my X and Y intercepts and had to shade and pull off the corners, which, you know, the ones on the axes aren't bad, but I had to do the exact same thing right here to go find that. So it coincides. So do those problems and see how they go. Thank you.